Hello guys, so today we'll try to solve this question Leetcode 1464 max product of two elements. So it's a fairly simple question and I'm sure many of you might have already done it, or if you see this question you will be able to easily solve it. So our major goal is not to solve this question but to understand how we can use different approaches, different algorithms and data structures to solve a question and get the best possible result. And by best possible result means most efficient solution. Alright, so the question is pretty much simple. What we have to do is that we are given an array, like when we take this example. So here we have an array which consists of element 3, 4, 5 and 2, right? So we have these number of elements here. Alright, and what we have to do is that we have to return the product of maximum two elements, two maximum elements, right? So here, the two maximum elements are 4 and 5, right? Their product is 20, but you can see the output is 12, right? So the catch here is that all we have to do is that for the first maximum element, we have to reduce one from it, and the second maximum element, we have to reduce one from it, and the sorry, resultant value will be our answer, right? Similarly, we can see in this array, the maximum two elements are two fives, right? So 5 minus 1 and 5 minus 1, that is 4 cross 4, which is equal to 16. Okay, and firstly, forgive me, my handwriting is pretty bad, but I'll try to be as detailed as possible. And I'll try to write most number of steps by myself, and I'll try to speak those steps as well so that I won't miss anything. And if that happens, I deeply apologize for that. Okay, so the first approach, I think the first approach that you all would have thought of is, I'm sorry, this pen tab is giving me a really hard time, right? So approach one, इसमें हम क्या करेंगे? First thing would be to sort the array, right? हम एक बारी में array को sort कर देते हैं, and it's our choice. We can sort it in ascending order, right? And we can sort it in descending order as well, right? Well, when we're using built-in functions, I would prefer to sort it using ascending order because, sorry, not ascending, descending order, because in that case the first two elements will be our maximum elements and we won't have to calculate the length of the array, right? But for the ease here, we'll won't use any other things. So like we are not going to use collections for sorting. So we'll use just arrays sort. So we'll sort the array in ascending order, right? And the second step would be to calculate the length of array. Right? And well, this can be the first step as well. So this is not a step. And the last would be will return the product of second last element, which is n minus 2. We'll subtract 1 from it, and the last element of array and minus 1, right? So this will be our answer. Now this would be our first approach. Now here what we did is that we used sorting algorithm. Now what would be the case if we have to use a data structure, right? So approach 2, Here, we're not going to use any algorithm, but we'll take the help of max heaps. And by max heap, we all know it's priority queue. So step one would be will insert or push all elements of array in the priority queue, and in that max heap the first two elements would be our maximum values, right? So we'll pop the elements two times, right? Let's say first element is a, second element would be b, then we'll return a minus 1 into b minus 1, right? This is also a simple solution. The last solution is the most elegant solution. And why I'm saying this? Because in the first approach, you can see, first when we calculate the length of array, right, it will take O of n time, okay? And when we sort the array, it will take O of n log n time, right? This is the best possible time for sorting an array. We use merge sort and quick sort, right? So basically the overall time complexity would be O of n log n, right? Now in max heaps, we know that by default we use a tree to store elements in a max heap, right? Yeah, though it's an array, but we store the values with the, like in the form of tree. All right. And when we push an element in an array, it takes log n time, right? And pushing n elements of array, it's gonna take n log n time. So ultimately the time complexity also would be n log n, and in this particular case we are using some space as well. So ultimately using priority queue, the solution is fine, but it's not at all efficient, right? And in the first case the solution is good, but it's not efficient because we are taking n log n time. So what we can do is that using only one loop, we can calculate both first maximum element and second maximum element, right? So what can we do? Initially, let's say the first maximum element is minus infinity and the second maximum element is as well minus infinity. Alright, so we'll go through a loop, and now, okay, so in this loop, we'll have our first condition. If this nums of I, I'm really sorry, this pen tab really is, you know, okay, this nums of I, if it is greater than f, right, what we'll do is that we'll update s to f and f to what? Nums of I, right? And we'll continue. We'll break the loop here and continue to the next iteration, right? And suppose if nums of I is not greater than f, then what we'll do? Then we'll keep a check on whether nums of I is greater than s. And if it is greater than s, what we'll do is we'll just update s to be nums of I. Pretty much fair enough, right? So we'll try to do a dry run as well. Suppose we have an array, let's say 8, 1, this is 4, 3, and this is 5, right? And initially this f is negative infinity and s is also negative infinity, right? So let me write it more clearly here. Okay, all right. So when we are on the first element, right, that is a, we can see 8 is greater than f, right? So what we'll do is that s is equal to f, which is already negative infinity, right? And f will become 8 and we'll continue. Fair enough. Now in the second one, 1. Now 1 is less than f, right? So we'll move to the second if statement in which 1 is greater than s, right? So this implies we'll update s as 1, right? Now we'll go towards the third loop. Now in this case, the element is 4. 4 is again less than f, but 4 is greater than s. So we'll update s to be 4, right? Now in this fourth iteration, the value is 3. 3 is less than f and 3 is less than 4 as well. That is s, right? So we'll just leave this, and in the last iteration, f, 5 is less than f, right? But 5 is greater than s. So ultimately s will be updated to 5. So ultimately our f is 8 and s is equal to 5, right? So we have got the first two elements, and by subtracting 1 in each of these elements, we'll just return the product. Okay, so now let's move to the coding part. So let's dive into the coding section. Alright, now we'll try to solve the question with the first approach, that was the sorting approach, right? So we'll try this. Alright, so first we'll try to calculate the length of array, that is nums dot length. Alright, now we'll sort the array. So arrays sort, sorry for that, and we'll put nums here. Okay, now simply just return the product of second last element, that is nums minus 2 minus 1 star the last element, that is nums minus 1 star, I'm sorry, 1. Okay, तो सबमिट करके देख लेते हैं. Okay, so यहाँ पे एक दिक्कत है. So let's submit it. Alright, ये submit हो गया. Now we'll try to use a different approach. Okay, let's improve the indentation a little. Right. Okay. So let's comment this out, and this time we'll use using priority queue. And also priority queue, I'm referring to max heap. Now by default in Java, priority queue comes as a min heap. So to convert it into a max heap, to use it as a max heap, we'll have to use collections library, right? So priority queue, we have to use this as an integer, right? Okay, and all right, we have used collections.reverse order here, and this is our max heap. Now we'll use a for each loop for our convenience to push all the elements in the heap. Okay, now as we wrote in the algorithm, we'll pop the first element, then we'll pop the second element. Alright, and we are going to return the product by subtracting 1 from them, and let's try to submit it. Uh, what's the mistake here? Illegal starting of expression. Oh, I'm sorry. I'm really sorry. Alright, so you can see we are in this domain right now, right? And we have to reach this domain. So using priority queue, the solution is nice, but you know, not efficient. Now I'll move towards the most efficient solution. I'll just comment this out and best approach. Alright, so here our first element, the first max element is I should keep it as min value only because it's negative infinity, right? And we are going to use the same value again. So this time the value would be s. Now again we are going to use a for each loop. It really makes our life easy. And in the first if condition, what we decided was that if that number is greater than f, so we'll update s to f and f to that number, and we'll just continue to the next iteration, right? And if that doesn't happen, right, then we'll put again a check on s, and if it succeeds, then we'll put s as I, right? And the loop is over. Now we have this first max and second max element. So what we'll do is that return the value by subtracting 1 from it, and let's try to submit it. And see, now we are in this region. So ultimately the point was that sometimes in the interviews the questions that are asked are pretty much simple, but what the interview is expecting is that you have to solve the question in the most efficient form. So the question would be simple, and if you go through brute force approach, or if you try to apply a different data structure which doesn't give an efficient solution, then there's a possibility that you might get rejected. So ultimately the most important thing is to, think in the most non-trivial way. Go with the basics and try to solve it as neatly as possible, and try to visualize what you're trying to implement. So I won't use these stupid words again. So ultimately with these videos I'll also be learning a lot, and I hope if you're watching this video, you like the content, and I'll try to improve upon it, and especially my writing skills. So sorry again for my writing, but I'll improve upon it. And I hope whatever the solutions were there, you like those solutions, and I'll try to improve again. So see you in the next video. Thanks for watching.